Students, I am audible, ma? Students, it is audible, ma? Hello.
Yes, sir.
Wait, ma, 2 minutes. After joining the all students, we start the class. Ma. Within 2 minutes, we start our class, ma.
Yes, sir.
Okay, ma. Okay, ma. Students, whiteboard is visible, ma?
Yes, sir.
Okay,
Yes, sir.
right. Students, all of you listen me carefully. Please, all of you unmute your video audios. Just listen what I am telling. Carefully you follow the concepts, ma. Here,
అందరినీ అన్మ్యూట్ చేసుకోమని చెప్పండి సార్.
please
డిస్టర్బెన్స్
all of you unmute your audio. Okay, ma. But don't write anything on the whiteboard, please. Students, today we are going to discuss about the lasers. Here, laser is one of the chapter in third unit. It is coming under first mid. That's why we are discuss about the laser, ma. In our offline classes, already we discuss about the interference completely. And also we have the diffraction. In first unit, what is the name of first unit, ma? Wave optics.
optics, sir.
In wave optics, already we complete the interference. We complete the first chapter in wave optics, that is interference. Diffraction is there, another second chapter in first unit. Later we discuss about the diffraction, ma. Already we complete the interference. Today we go through the that new chapter, that is the laser. Okay, here laser is a device. Students, laser is a device. It is a one kind of device which amplify the light. Amplifies the light. So laser is a one kind of optical amplifier. Laser is a one kind of optical amplifier. Already you know, man, at your intermediate level, you know about the transistor. Transistor used as a electrical amplifier. That means it is increase the strength of the weak signal, weak current signal. In the same manner, the laser device increase the intensity of ordinary light. Increase intensity of the ordinary light. So here, laser is a device which amplifies the light. Here in the laser, we have LASER. The L means, please all of you unmute your audio. Students, all of you unmute your audios. Okay, so here in the laser abbreviation, we have the L. L means light. A minute. L means light, where A is the amplified. By where S is stimulated emission of radiation. Stimulated emission of radiation. Here laser is an abbreviation for, what is that, man? Light amplified by stimulated emission of radiation. So here we amplify the light by the stimulated emission of radiation. Already you know, ma, laser is a device which amplifies the light. By which process? By the stimulated emission of radiation. So laser is a device which is used to increase the intensity of light or amplify the light properties through the stimulated emission of radiation. So here, what is stimulated emission? What is absorption? What is spontaneous emission? Now we discuss. So here, how we abbreviate the laser, ma? Light amplified by stimulated emission of radiation.
Radiation.
Okay, light amplified by stimulated emission of radiation. So here, if we want to produce the laser, or if we want to amplify the light, if we want to amplify the properties of light, we need to interact the, 1 minute. We need to interact the matter with external energy. So to amplify the light by stimulated emission of radiation, we choose one process, that is the interaction of matter with external energy. Interaction of interaction of matter with external energy. So here we amplify, we produce the stimulated emission of radiation by which process? By the interaction of matter with external energy. So to amplify the light, What we choose, ma? Which process we choose? We interact, we take the interaction of matter with external energy. For example, this is the matter. This is the one substance, ma. Suppose this is the solid substance. If we supply the external energy, if we bombard this matter means substance here. If we bombard this matter, if we interact this matter with the external light energy h nu, what happen? Few number of atoms are jump from ground level of the matter to ground level of the matter E1 to excited level E2. Some atoms are jump from ground level to excited level, ground level to excited level without emitting any radiation. This process is called absorption. Process is called absorption. So here, to move the atoms from ground level E1 to move the atoms from ground level E1 to excited level E2, what we do, ma? Just we interact the matter with external light energy. Due to that, what happened? Some radiation density absorbed by the matter surface. Due to that, few number of atoms are jump from ground level to excited level without emitting any radiation. This process is known absorption. Right. Next, after absorption, already we have this situation. Some number of atoms are there in excited level. Few number of atoms are there in excited level E2. These atoms are again transisted from excited level E2 to ground level E1 itself. These atoms are transisted from excited level to ground level E1, excited level E2 to ground level E1 by emitting radiation itself, by emitting the light energy itself. So here, after absorption, this is the situation. After completing the lifetime of the atom in excited level, after completing of these atoms in excited level, actually atoms are spent 10⁻⁻8 second time only in excited level. After completing this time, all atoms are transisted from E2 to E1 by emitting radiation itself. Itself means without taking any energy, So that's where this process is not spontaneous emission of radiation. Here, first one is the absorption. This is the absorption. Absorption means when we interact the matter, all of follow this red mark. When we interact this matter with external light energy, what happened? Due to absorption of some radiation density h nu, few atoms are jumped from ground level to excited level. This process is called absorption. Okay. Next, here after absorption we have this situation. That means atoms are there in excited level. These atoms are again falls from excited level to ground level by emitting radiation. This process is called spontaneous emission of radiation. Please, don't make noise, ma. Please, all of you unmute. Here we record all the participants' details. All of you unmute. Jargavi. Here M. Jargavi talking. Please unmute, ma. What are you doing? Just you on the mobile and kept in the before the TV. Here, this process is called spontaneous emission. Spontaneous emission. Next, after spontaneous emission, we have another process, that is stimulated emission. That means the radiation emitted by the spontaneous process used as the external energy. Due to that, atoms are transited from excited level E2 to ground level E1 by emit the radiation in the direction of incident photons. In the direction of incident, these are the incident photons. These photons emitted by spontaneous process. These photons emitted by spontaneous process. So the photons emitted are the radiation or the light energy. This is the light energy. H nu is the light energy. The light energy emitted by spontaneous process used as the external energy to produce the laser emission. To produce the laser emission continuously due to falling of atoms from excited level E2 to ground level E1. So here, this is the absorption, this is the spontaneous emission. Last process is the stimulated emission of radiation. Stimulated emission of radiation. Here, in these three processes, stimulated emission of radiation only used to produce the laser radiation, because here photons are incident in this direction. Light also emitted in the direction of incident photons. That's why it have high directionality, monochromaticity, high intensity, and coherence. That's why we said from the beginning of the class, we said laser abbreviate as light amplified by stimulated emission of radiation. Light amplified by stimulated emission of radiation. So what happened when we interact the matter with external energy? This external energy may be subjected to absorption, spontaneous emission, or stimulated emission of radiation. Stimulated emission of radiation. So already you know H nu is equal to E2 minus E1. Emitted radiation energy is equal to excited level energy minus ground level energy E1. Excited level energy E2 minus E1. Frequency nu is equal to E2 minus E1 by Planck's constant. E2 minus E1 by Planck's constant h. So this much of frequency emitted by the both spontaneous and stimulated process. But in stimulated process, all emitted light rays travel in same direction. But in spontaneous process, light emitted in different direction. That's why it have poor qualities, but it have good qualities. Spontaneous emission of radiation have good qualities. So here, students, if we want to produce the laser, what do we do? Tell me. Just we interact the matter with the external energy. Students, is it audible, ma? Hello, students.
Yes, sir.
Yes, ma'am. Okay. Here, what is the principle in the production of laser? In interaction of matter. Interaction of matter with external energy. So this interaction of matter with external energy undergoes in three ways. This interaction of matter with external energy undergoes in three ways. What is that, ma? One is absorption. One is the absorption. Second one is, what is that, ma? Spontaneous emission of radiation. Spontaneous emission of radiation. Next, third process is, what is that? Stimulated emission of radiation. Stimulated emission of radiation. So when we interact the matter with external energy, what happens? It undergoes three ways. This process takes place in three ways. That means this is the matter, already you know. This matter interacted by external energy. That external energy in the form of light or in the form of chemical or any. Here we explain by taking the light energy. H nu is the light energy. By interacting this matter, with external light energy, what happened, ma? Few number of atoms are jump from ground level E1 to excited level E2. This process is called absorption. Okay. So what is absorption, ma? When we interact the matter with external energy, few number of atoms are, some number of atoms are jump from ground level to excited level without emitting any light energy. This process is called absorption. Okay. After absorption, what happens? See this. Already you know, after absorption, atoms are there in excited level. This is before absorption. This is after absorption actually. Again, we draw the after absorption. This is the after absorption situation. After absorption, what happened, ma? Some number of atoms are there in excited level. E2. Here, after completing the lifetime of the atom, here, what is the lifetime of an atom in excited level? 10 power minus 8 second. 10 power minus 8 second. Okay. After completing this lifetime at excited level, atoms are spontaneously, that means itself, transisted or falls from E2 to E1. Atoms are falls from E2 to E1 by emitting light energy in different directions. Itself. This process is called spontaneous emission of radiation. Next, after spontaneous, what happened? These photons are released. This light energy is released. This light energy used as the external energy. Again, we observe the continuous transition of atoms, continuous falling of atoms from excited level E2 to ground level E1. Excited level E2 to ground level E1 by emitting the light energy. In the direction of these incident photons. These are incident in this direction. Emitted photons are also coming in the same direction of incident photons, incident light energy. Here we supply external energy. In this diagram, here we supply the external energy. That's why this is called stimulated emission. Here we don't supply any external energy. That's why it is spontaneous. But here, due to absorption of some radiation, atoms are jumped from ground to excited level. This is absorption. This is after absorption situation. Both are same. These two diagrams, 1, 2. This is spontaneous emission. This is the stimulated. So, in these three process, which is suitable to produce laser? This process, stimulated emission of radiation, because photons are incident in this direction, and also emitted photons are also in the direction of incident photon. That's why laser travel long distance. Laser travel long distance with fixed wavelength. Laser travel long distance with fixed wavelength. So that's why the stimulated emission process only used to produce the laser radiation. Already initially we said here LASER, laser is, how we abbreviate laser? Tell me once again. Light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. So that's with actually interaction of matter with external energy you require to produce the laser. But in these three interactions, third interaction only used to produce the laser radiation. The third interaction is the stimulated emission of radiation. Students, is it understand, ma? Hello?
Yes, sir.
Yes, sir.
From the beginning of the class, only we discuss about what we do to produce the laser. What we do to produce the laser.
Laser.
What we do, we interact the matter with the external energy.
External energy.
Okay. So the radiation produced by this process, by the stimulated process, have 4 advanced characteristics. The radiation produced by the stimulated process, stimulated emission of radiation process, have 4 advanced characteristics. Here, 1 minute, ma. Through the PPT, you observe the what is stimulated, what is absorption. Wait, ma. I am trying to share the PPT regarding absorption, emission, stimulated emission. Okay.
Okay.
Wait, ma. 1 minute. Students, first topic is production of laser. What is that, ma?
Laser.
Production of the
Production of lasers.
laser. Here,
Lasers.
if we want to produce the laser, what we do? Here, we interact the matter with external radiation or external energy. This external interaction of matter with external energy undergoes 3 ways: stimulated absorption, spontaneous emission, stimulated emission. See this definition of stimulated absorption. Here atoms are jumped from ground level. This is the atom. Atoms are jumped from ground level to excited level by absorbing some incident radiation. Here we don't observe any emission of radiation. Here we interact the matter with external energy. Due to that, atoms are jumped from ground level to excited level. This process is called absorption. This process is called absorption. Because external energy is supplied, that's why it is called stimulated absorption. External, if you supply the external energy, that is called stimulated process. So here absorption observed due to stimulated. Next, go to another slide. Wait 1 minute. Only today 23 members are joined, ma. By tomorrow onwards, trying to join all the students.
సార్ మీ వాయిస్ స్ట్రక్ అవుతాను సార్.
Maybe because of poor internet connection, sometime it happens.
వాయిస్ కట్ అవుతాను సార్.
వాయిస్ కట్ అవుతాను సార్.
Wait, ma. Now, ma. Present, okay, ma.
నో సార్, ఇప్పుడు కట్ అవుతాను సార్.
ఇంతకు ముందు మా ఇంతకు ముందు బాగానే ఉండిందా స్టార్టింగ్ నుండి? హలో,
ఇంతకు ముందు బాగానే ఉన్నింది సార్, ఇప్పుడు
ఓకే.
స్ట్రక్ అవుతాను. ఇంతకు ముందు బాగుంది సార్, ఇప్పుడు స్ట్రక్ అవుతాను సార్.
వెయిట్ మా, అంటే ఒకసారి అందరూ వాడుతూ ఉన్నారు కదా ఫ్యాకల్టీ డిపార్ట్మెంట్ వైఫైని, అందువల్ల కొంచెం కనెక్షన్ నెట్ స్లోగా ఉంటుంది. ప్లీజ్ ట్రై టు అండర్స్టాండ్. హియర్ PPT is visible, ma?
Okay.
Okay. So next process is spontaneous emission. Spontaneous.
Yes, sir.
Yes, sir.
Now it is audible, ma? Hello, students. Now it is audible, ma?
Yes, sir.
Okay. So here how we define the spontaneous absorption emission. See this. After completing wait, ma. After completing lifetime of atoms, what is the lifetime of atom in excited level? 10⁻⁻8 seconds. After completing lifetime of atom in this excited level E2, atoms are transisted from E2 to E1. This is called spontaneous emission of radiation. Spontaneous emission of radiation. So please all of you unmute your audios.
Yes.
So how you define spontaneous emission, ma? Read this definition. After completing lifetime of
After completing lifetime of atom,
at E2, atoms are transisted from E2 to E1 by emitting
from
radiation
E2 to E1 by emitting radiation
without taking any external energy. This radiation have poor monochromaticity because it is emitted in different directions.
poor monochromatic.
Poor monochromaticity means it emitted in different directions. Emit in this direction or in this direction, in this direction. Here we don't use any external energy. That's why it is called spontaneous emission of radiation. Next, go to next slide. One minute. See this last slide, ma. What is that? Atoms are stimulated emission. How you define stimulated emission? Atoms are transisted from E2 to E1 by emitting radiation by taking external energy. This radiation have frequency nu is equal to E2 minus E1 by Planck's constant, where E2 is the energy of excited level, E1 is the energy of ground level, nu is the frequency of this emitted radiation. Here these are the photons emitted by spontaneous process. These photons used as external energy. Due to that, atoms are transisted from E2 to E1 continuously measure the laser emission. So this is the stimulated emission of radiation. This is the definition of stimulated emission of this process only produces laser. Desita sounds vastundamma. Okay. Next, Purva Hari. All of you unmute your audios, please. So today, from the beginning of the class, what we discussed, ma? Just we discussed the production of laser. Production of laser. So to produce the laser, to produce the laser, what we do, ma? We interact the any substance or matter with external energy. This interaction takes place in three ways: stimulated absorption, spontaneous emission, stimulated emission. Stimulated emission. Students, if If time is
Yes.
completed, automatically class is disconnected, ma. We will meet next class. Okay.
Okay, sir.
Wait, ma.
Try 20 minutes.
Okay, ma. If we want to produce the ledger, what we do? You need to interact or bombard matter with external energy.
Voice break అవుతుంది.
What?
వాయిస్ బ్రేక్ అవుతుంది సార్.
Wait, ma. Now, okay, ma.
Okay, sir.
Okay. So, just today we discuss about what is stimulated absorption, what is spontaneous emission, what is stimulated emission. In these three process, last process, this is stimulated emission only used to produce the laser. The laser emitted by this process have four main characteristics. The laser emitted by this process have four main. That four characteristics are. See this. Wait 1 minute.
Okay, sir.
Here one is the high directionality, intensity, and monochromaticity and coherence. So tomorrow we discuss about the that are the characteristics of laser. Friends? Students, PPT is visible, ma?
Yes, sir. Stuck అవుతుంది సార్ అప్పుడప్పుడు.
మీ వాయిస్ స్ట్రక్ అవుతుంది సార్.
Okay, ma. Actually, class is from 11:05 to 11:45 only. Now time is completed, ma. Tomorrow we will meet and discuss about remaining topics. Okay.
Okay, sir.
LR, please share the today's attendance
Okay.
to my personal WhatsApp number, ma. Not in group. Okay. Right. Thank you.
ఓకే సార్.
Bye.